This is number 4. The Parks Department wants to put tile around the outside of a circular wading pool. Estimate the number of square feet of tile that are needed. I'll give you a second to copy that down if you're working at home, this image. So basically, the big picture is that I have a wading pool, and around it, tile is going to be installed. Don't waste money, basically. We're not going to buy tile for this whole area because all the tile in the center would be a waste. So then, we got to figure out, is this going to be an end-to-end problem or a door with window? And if we think about it, I'm going to have this amount of tile to begin with if I were going to tile everything up, but then there's the wading pool. So then I'm subtracting out the circle. I'm just taking this out and getting rid of it. So then this will have to be a door with window problem. So then what I'm going to have to do is I'm going to have to figure out the area of this big square and subtract out the area of the little circle. Looking up the formulas on the formula sheet, I'm going to find out that area of a square is side to the second power, side squared. Area of a circle, when I look it up in the formula sheet, is going to be pi times radius squared. Let's do what's easiest first. On the assignment, it tells me that the square is 20 by 20, so then 20 to the second power is going to be 400 square feet for the area of the plaza. Now I start finding out the area of the circle. Pi times radius squared. It tells us that the radius is 7. So now using the rules of Aunt Sally, I have to work out the exponent first. 7 times 7, 49 times 3.14. When I do the math, I'm going to figure out that this is going to have a product of 153.86 square feet. So now, let me just erase some of the clutter so that it'll start making some sense. Make sure that everything's all caught up. So then, in other words, what this is telling me is that the plaza would occupy about 400 square feet. The only problem now is that the wading pool is there, so whatever is in here, the 156 square feet, 153 square feet is going to be removed. So whatever is left around it would be kind of like the outside of the pool. So all that's left is to subtract them from each other because it's being pulled out. So then when I do the 400 minus the 153.86 is going to tell me that the amount of tile for the outside of the wading pool is going to be 246.14 square feet. So then I would basically have 246 1-by-1 squares all the way around the wading pool. If you wanted to go for the throat, and if you're a little bit more advanced with the Aunt Sally and these geometry terms, you can look at the problem, you can identify the shapes, They're correct formulas, and if you wanted to write this problem directly and use the Aunt Sally format, you could have started off like this. Then you would fill in the blanks and solve for it. And if you're not quite getting this yet, that's okay, you'll build up to it. But if you're more advanced, you can just start creating your own formula almost and just start solving for it. Because this right here, 20 to the second power, would represent the area of the square that we started with. This right here, pi times radius squared, is the area of the circle. Just make sure that everything's closed within parentheses just to keep everything nice and neat and avoid confusion. So then 20 times 20, using the rules of Aunt Sally, it's going to come out to this. And then when you do the math, it's going to come out to the exact same thing. So if you're more advanced and you want to try this, then you could do that.